Okay, hopefully we are now live on YouTube. Welcome, folks, to this next exciting installment of Cloud Native Manchester. This one, isn't it? I'm slightly losing track of which virtual event I'm presenting at the minute. So it's been a while since I've done one of these, so I'm sure it's all going to go horribly wrong. So joined today by two of our fantastic organisers, Nick and Jenny. Hello, folks. And also our great speakers for today, Ben Elgar and Martina Catazzone, who's presenting with Jenny later on. So let's kick this whole thing off. Ben, I had a poke around on your website before we went on air. Crucible sounds super interesting, and a space I'm kind of familiar with about testing Kubernetes. So how did this all come about?
So really it came about because I worked at sort of MLab, which was a MongoDB hosting company, and then I worked at MongoDB following that. And at both companies, I ended up building basically the same thing, right? Like I built this sort of, testing harness for running Kubernetes, like running tests on Kubernetes, constantly like spinning up Kubernetes clusters, tearing them back down again, cleaning up after having done so. And it was kind of like, in both cases, I did it kind of mediocrely, right? Like I didn't have the sort of like, time to do it in the way I wanted to do it. And so, this was sort of my my effort to do it right, and come up with a product as well at the same time. Should I answer the question?
Yeah, it does. No, it's great. So, I mean, Crucible, is that your full-time gig now then?
Yeah. Yeah. So it's nice. Yeah, I sort of, it's for the last couple of months I've been working on it sort of full time, and it's sort of, been reasonably successful. Had quite a lot of interest, and sort of. Well, I've never had to do enterprise sales before. This is what I'm finding now. It takes a long time. Didn't realize why we paid people quite so much money, and now I get it.
Yeah, I mean, it's an interesting space, isn't it? Because I mean, there's I've spent a lot of the last 18 months involved in the operator space, and that's an awful lot of building up Kubernetes clusters and tearing them down again, and building new ones and tearing them down again to test operator development. And so I've used a lot of Kind and a lot of Minikube, and there's lots of different ways to skin this cat, right?
Yeah, totally, and that's part of what I'll go into, but cool.
I don't want to spoil your presentation before.
I won't like rip out half of slides and dump them in right now. But that's fair. Yeah, in general.
Was that how you got into kind of Kubernetes and cloud native software to start with, then through developing stuff for it?
Yeah, so actually it was at a company I worked at before, at MLab, where we did we were sort of building this sort of Kubernetes, like this orchestration platform that sat above Kubernetes. The idea being it was sort of a simpler layer that people could, we would host their apps and their database, and it would all be co-located together. It was very nice and fancy. We ended up getting acquired by MongoDB, so we didn't ever pursue that goal. There's some open source skeleton of this project left somewhere, but this was, part of this was getting involved with a lot of Kubernetes stuff, and essentially creating, like, in order to test this platform, creating a lot of Kubernetes clusters. And this was how I kind of got stuck into it quite early on. And that was a great introduction into and watching the ecosystem grow has been really exciting.
Yeah, I mean, it was interesting you said about building systems to make Kubernetes easier to use. It's certainly something I've talked about a lot over the last few months, that Kubernetes is far too complicated for actually deploying applications onto, and that I'm still surprised that there aren't more PaaS layers being built on top of Kubernetes. I mean, when you start looking at a deployment file and think about how much of that deployment file an application developer gives a crap about, it's almost none of it, right?
Yeah, no, totally. I do. That's what we thought at MLab, and that's where we were going until the acquisition. But I still buy that at some point. Like, I think Pulumi is the closest product I've seen to sort of like really streamlining the the process of you know, basically generating that, writing less boilerplate, making it feel a bit less, a little bit less convoluted. I mean, it's not easier, but it certainly strips away a bunch of boilerplate that you don't necessarily need to write anymore, and integrates a whole bunch of things together in a way that you don't get with Kubernetes by itself.
Yeah, I mean, I think that, the original goal of Kubernetes was to be this, this super easy platform for application deployment. But I think, once something becomes this pervasive, it ends up with everything and the kitchen sink in it, and to be that generalized use case. So I definitely can see there's a space there for someone to make the Heroku of Kubernetes over the next couple of years.
Yeah, totally. And I remember when, there was this whole notion that there wasn't going to be much storage option within Kubernetes, and then it became much more supported. So that was an interesting sort of, evolution of
start on service meshes.
Yeah.
Hi, folks. I noticed a few people saying hello in the chat there. Thanks for joining us. So what else have we got to talk about, Nick, before KubeCon next week after next? Who's going? Well, going virtually.
Hoping to.
At home, I think.
Yeah, I'll see if I manage this. It's busy weeks, but yeah, I'll have a look to see if I can fit it in.
It's a funny one, really, but because by going virtual, it's difficult to actually block out the time required to actually attend all the sessions. And then, of course, there's just, there's so much value in conversations you have in hallways and, people that you catch up with, you don't see that frequently. So when you think about it just as like a virtual event, and it's right slap bang in the middle of a working day that, you have to fit around your existing working schedule. It's sort of lower down in the list of priorities than maybe it should be, which is, kind of a shame.
Now,
and then, of course, there's always the excuse. Well, then there's always the excuse of, I'll just watch the sessions afterwards. And then, of course, they never get watched. Yeah. Or you go back to watching them 6 months later, and you're like, everything in that space has changed anyway. So there's no point in watching that stuff. It's all been replaced by something completely different.
So you may as well have not bothered to start with.
Yeah, basically, yeah.
Kubernetes, what's that?
Sensible advice.
I think they're going to use it. They're using a platform that I haven't actually used before. So I'm quite interested to see how that works out. I know they've spent a lot of time thinking about these problems of hallway tracks and engagement and all that stuff. So it'll be interesting to see whether they've managed to solve that. I have heard some feedback from some of the other big conferences. I think the AWS one, folks said, was did actually work pretty well in terms of community engagement. So I think KubeCon will be the big test of whether people can make these virtual platforms work, effectively for community engagement. Right. Well, I guess we're about time to kick things off. So I think Nick, are you driving the buttons here?
Oh yeah, sure. I'll move a few things around. Yeah, I'll drop those out,
hooked up and ready to go,
and give Ben the floor. Right. Let's.
Oh, grand, cool, perfect. Well, hello, hello everyone. I thank you all for taking time out of your busy Thursday evenings to come and listen to me talk or listen to us talk. I especially with a title like Independent Testing Environments for Kubernetes, I was trying to come up with something more pithy. I didn't really succeed, but exciting title, I know. But that being said, I do think that this is it's a really important component of building confidence in your testing procedures, having these independent testing environments. So I do think it's important, even if not the most exciting title. But before I dive in, I thought I'd do a little introduction about myself. You got some of that from the talk before, but I am a software engineer by trade. I previously worked at MongoDB. I worked on their enterprise Kubernetes team. There I help them build tooling basically to run MongoDB at scale inside of Kubernetes. But now I am the founder of Crucible. Crucible is a platform for creating Kubernetes clusters for testing and development. And indeed, that is, a significant part of the reason I want to talk to people. It's because I believe that Crucible is the best way of creating Kubernetes clusters for creating these independent environments for testing Kubernetes. But that being said, I don't want you to think of this as a sales pitch. That's not the idea. The idea is, it's a collection of information that I and a couple of other people have taken away from, building systems like this over the course of a couple of years now. And yeah, I hope that it, is useful aside from that. So before I think the first thing that is important to do is define what I mean when I talk about what kind of tests I mean when I'm talking about independent testing environments for Kubernetes. And the kind of tests that I'm really talking about are end-to-end and integration tests. These are the tests I'm primarily referring to. In other words, these are tests where the aim of the test is to take some system of applications along with some associated configurations, some secrets, and basically run this set of applications that you would have run inside of Kubernetes and check the emergent properties of the system as a whole. Now, assuming you currently are running Kubernetes, so imagine a lot of people are, I want you to think about how you're currently running this kind of test. In our experience, there's a few different ways that people are doing this. And the first way I'll talk about is, one that surprised me. It would surprise me or at least surprise me as to the prevalence of this in the real world. And it was to simply not bother, right? It was people will run, take these systems of applications and a set of microservices, and they'll test each service within the set individually. And then they will assume that if each test, every test passes, then all of the services should work together appropriately. Now, I totally get why people do this, right? Because it's easy. It's the simplest way forward, right? There's nothing easier than not writing any tests and allowing your existing tests to sort of carry the weight. But in practice, part of the reason it's easy is because it doesn't catch a whole bunch of real world problems. And if you're not catching them in your test environment, you will catch them in your production environment when you try and deploy. And perhaps one of the most important things that this doesn't test is the actual Kubernetes configuration that you're going to deploy in your production environment. And as I'm sure anyone who has spent any non-trivial amount of time working with Kubernetes will be able to tell you, Kubernetes configuration is extremely powerful. You can do a whole bunch of stuff with it, but it's also extremely complex. And with all of that complexity comes a really easy ability to mess it up, right? It's extremely easy to typo something, within your, even to make, typo a field name and have a completely nullify a type, partly because of YAML's sort of type inference system. You don't have it's not particularly strict. So it's extremely easy to make mistakes. And these are mistakes that you'll only catch in production if you don't test them in your testing environments. So given that we want to test these things, what are the mechanisms that people do use who test them? So one mechanism that I see and is quite prevalent is to test their sort of systems, but test them outside of Kubernetes, right? To run these Kubernetes, run these end-to-end tests, but do them outside of Kubernetes. Usually using a simpler orchestration system like Docker Swarm, or perhaps a set of custom bash scripts. And this is a hell of a lot better than not running any tests at all. Primarily, you can now test your sort of domain-specific logic. You can test that your services are at a high level functioning, and you can test the sort of the domain logic in a business logic. That being said, there are still a bunch of issues, right? Your orchestration system, primarily your orchestration system, now has a completely different set of characteristics to the one that you're running in production. Your services will start differently. They will receive configuration differently. They'll be in a different network environment than they would be in their production environment. And all of these things have a real potential to impact the functionality of your services. And again, the place you will catch this, if not testing, I'll say this a lot during this, but if the place you will catch this is in production, if you're not testing this before. And again, you're not testing the Kubernetes configuration by definition. You're not testing the Kubernetes configuration if you're running your tests outside of Kubernetes. So if we want to run our tests inside of Kubernetes, what are our options? Well, one mechanism that a bunch of people use is to run their tests inside of Kubernetes namespaces. So this often looks like, and this works for a bunch of use cases, but it often looks like creating a new Kubernetes namespace for every new test run, and then deleting the namespace afterwards. This is a lot better, again, than not testing inside of Kubernetes, largely because you're now testing most of your Kubernetes configuration, right? Your namespace looks your network environment looks very similar. Your services will receive configuration in a very similar way. So this is very helpful. You gain a lot of value from it. But I did say most of your Kubernetes configuration because there are still a bunch of resources that you can't test if you're running within a single namespace. The most obvious examples are things that are scoped at a namespace boundary. So, for example, a namespace. You can't deploy a namespace within a namespace. You can't nest them. So if your application happens to deploy a namespace, or you want to test the rolling out of things within a namespace, rolling out new namespaces, you can't test that if you're sort of scoped to a single namespace. The other issue that people sometimes run into is that the tests now have the potential to impact other workloads that are running within their cluster. And it's also a cluster that they have to maintain. So this cluster, if you happen to co-tenant, for example, your test workload and your production workload, then your tests, if they consume a bunch of resources, have the potential to impact in a significant manner your production resources. I don't recommend co-tenanting these. And even if you don't co-tenant your tests and your production workload, your tests still have the potential to impact each other. So if one test consumes a whole bunch of resources, then it could cause another test to fail, an unrelated test to fail, through no fault of that second test, right? Like that second test wasn't broken, but it will show up as a failure to you. And you begin to lose confidence in your ability to judge that the tests are failing for the reasons that they are meant to, that they are appropriately testing the thing that they are meant to test. So once you've eliminated the notion of testing within a namespace, what you're kind of left with is the final option, which is running each test within its own dedicated Kubernetes cluster. Now, this at first might seem kind of heavyweight. Running a new Kubernetes cluster for every single test might seem expensive, requires a lot of infrastructure, feels like it requires a bunch of maintenance. In reality, there are now a whole bunch of new tools that make that a much more approachable, a much more reasonable task than it might have been, a year ago, 9 months ago. It feels a much more approachable task now, and it does come with a bunch of advantages. Perhaps the most important one is you can now test your entire and full Kubernetes configuration. This guarantees you a completely clean environment as well. So number one, you're no longer sort of scoped to namespaces. You're no longer worrying about whether you're testing things that will fall outside of your Kubernetes namespace. But it guarantees you a completely clean environment. It guarantees that you have it guarantees you a clean environment, and it also guarantees that you have no impact on any other workload, right? So there's no chance, by definition, that any other workload could have, any other test could have changed the state of the cluster in a way that invalidates future tests, and there's no way that any other test can come and interfere with your first running test. All right, so given that dedicated Kubernetes clusters might be a nice way of solving this problem, what mechanisms do people use? What mechanisms do people use to achieve that? What are these tools that I was speaking about earlier? Well, the first one I'll talk about is Minikube. I don't necessarily think, I don't speak about Minikube first because I think it's necessarily the ideal choice of tool for this job, but I speak about it because it's very familiar, it's very popular, it's often people's first introduction to Kubernetes. And the way that it works, at least traditionally, the way that it works is that it runs Kubernetes inside of a virtual machine. all of the components of a Kubernetes cluster inside of a virtual machine and exposes that over a network interface that you can then communicate with the API server inside of your VM. Now, actually, as of a few months ago, that's no longer quite so true. It creates the Kubernetes cluster within a Docker container now. There is now a Docker driver, which is very nice. That being said, the fact that it was originally created for virtual machines, I think, has meant that it's not quite as lightweight inside of, even within a virtual machine, even within a Docker container, as it might otherwise be. It maybe is a bit more heavyweight than the alternatives that I'll mention. The fact that it wasn't originally designed to be run from within continuous integration environments and continuous development environments also means that it doesn't necessarily have the interface that one might expect from such a tool. It doesn't also necessarily have the reliability profile that you might expect from such a tool. It's not necessarily the easiest thing to call out to Docker or to call out to a virtual machine provider from within, especially a containerized CI and CD environment. So the next tool I'll talk about is Kind. Kind stands for Kubernetes and Docker. As the name suggests, it runs the components of a Kubernetes cluster inside of a Docker container. Unlike Minikube, it's a lot lighter weight than Minikube, having been built from the ground up for this purpose, and is in fact the tool that the Kubernetes project itself uses to test Kubernetes. That being said, it is still a little. It's quite young. It's relatively young, though everything is young in the Kubernetes ecosystem. It's quite young, and it is still in beta. So that means there is no stable API. Things are prone to change now and then. And the manner in which you interact with Kind is by calling out to a binary and passing in the right command line arguments, which is fine, but it isn't necessarily, again, the easiest thing from within a containerized environment, because you are required to now have access to Docker that you could then be able to, this binary can then call out to. No, that's the same reason it's not necessarily the easiest thing, CI and CD. That being said, I do think that Kind is one of the best ways, if not the best way, of creating Kubernetes clusters for this sort of use case of testing and development available today. Partly because of its sort of, it's future-proof to a degree by virtue of its integration into Kubernetes itself. There are a couple of other tools that I'll talk about. I'll mention very briefly that I could talk about in more depth, but I don't have slides. They are microcates maintained by Canonical, Ubuntu fame. Similar, exposes a very similar interface and can be used for a similar sort of variety of workloads. It is a bit slower to start. And the other one I'll speak about is K3D. K3D actually under the hood spins up K3S, which is maintained by Rancher. It's a canonical, fully compatible Kubernetes distribution, though it's not running the exact same distribution of Kubernetes that you might be used to in most other settings. K3D starts very quickly. It's again running Kubernetes, running the components within a Kubernetes cluster, within a Docker container rather. But perhaps I personally lean towards Kind based on its integration into the Kubernetes build process. That being said, I'm talking strictly about self-hosted options. The one last thing I'd like to mention is Crucible. Crucible is a platform that I founded. It's a platform for creating Kubernetes clusters for testing and development, and it's particularly optimized for those use cases. So the clusters spin up really quickly, and they are cleaned up automatically when you're done with them. So you don't have to worry about building some cleanup process. Each cluster has its own dedicated hardware, so you're guaranteed to have a completely clean and isolated environment. The fact that Crucible is a cloud service means that it's really easy to use from within whichever CI and CD environment, within whichever CI or CD environment you happen to be operating in. There's no requirement for any sort of complicated dependencies. There's no requirement for Docker or a virtual machine provider. You just call an API, and sort of a few seconds later you get back a fully instantiated Kubernetes cluster. So that's not easy enough. We've got a sort of whole bunch of integrations with a number of popular CI and CD platforms, including GitHub Actions, CodeFresh, and CircleCI. Soon, very soon for CircleCI. Yeah, so that's the sort of spiel. What I'll do now is take my life into my own hands a little bit, do a quick live demo and see how that works out. Show you what it feels like to use the product or use Crucible in the real world. So this is the Crucible website. It's very standard software as a service website. I am not currently logged in, so I will log in and thank you, password manager. Here we go, and this will then take us to the clusters view, where you can see all the clusters that have been previously provisioned, that you've previously provisioned, and any clusters that are currently running. Creating a new cluster is super easy. All you do is you give it a name. Let's call it demo cluster. And then you specify a duration. So after this, so you can specify a duration anywhere between 1 and 6 hours. After that amount of time, so if you specify 1 hour, after an hour, the cluster will automatically be cleaned up. You don't have to worry about it. You can also choose a permanent cluster, which will continue running until you explicitly deprovision it. For the sake of the demo, I'll just choose an hour, and that'll do us. All we have to do, click OK. And he says clicking OK as nothing happens. Oh, there we go. Just didn't click OK. Yeah, and so now cluster goes away. Crucible goes away, starts creating you a cluster. This usually takes about 10 to 15 seconds to provision the cluster. I'm going to speak a little bit slowly as I wait for the cluster to now provision itself. Hopefully it's always... there we go. Takes a moment. So now we have a cluster. Connecting to the cluster is very easy. All you do, click the big connect button, and you select the mechanism via which you would like to connect to your cluster. There is a Crucible CLI that allows you to do all of this via the command line. But for now, I'll just show you kubectl, which is very familiar to most people who've used Kubernetes. All you have to do is copy this one command and then swap to a terminal, which I hope is big enough. I think that is big enough. Someone write in the comments if it is not big enough. Putting in so then you can, this command looks huge and very scary. In reality, all it is just inlining an entire Kubernetes configuration into sort of one command that then sets your kube config appropriately for kubectl. So I run that, and now I should be able to do, I'll just move down a bit. So there we go. And now I should be able to do kubectl, get pods, and get myself. So there's nothing in the default namespace, unsurprisingly, but I can select from all of the namespaces, and you can see this cluster has only just started. All of the pods are just a few seconds old. You can do exactly all of the same. One nice thing, sorry, I forgot a section. One nice thing about the fact that it's all running from within all running not locally, but on a real cloud provider's or from within a cloud provider means that you get access to all of the same cloud provider services that you would expect are now available to you from within Crucible. So to just to quickly demo that, I'll show you a very quick Kubernetes resource. It's very simple. All it's got in it is, it's two resources really. It's a pod that is just simple HTTP echo server. So all it does is when you make any HTTP request to this server, it just sends the word hello back. That's all it does. And then there is also a service that is a load balancer service that exposes that HTTP service. Not very interesting, but this is not very interesting, but this is plenty for the demo. Applying that configuration is just the same as you would say any other. I just run that demo, and then kubectl get pods. You can see that the service is running. I'll check the load balancer, and there we go. Now we have our load balancer, and it's, as you can see, it's gained an external IP address, and we should be able to curl it on that external IP address at the port that we have been provided, 32631, and it returns hello, which is what it should do, because that's all the server is doing. So that demonstrates that you're kind of running a real, like, exactly the same thing. Works for node ports and load balancers and ingresses. You can use all of these sort of services quite transparently in a way that you would expect to be able to. The other thing I'll show you is the Crucible CLI. Again, you can create clusters very simply through the Crucible CLI. Through the Crucible CLI. Exactly the same parameters as you would have specified via the website. Let's just call this CLI demo, so that you're specifying a name and then specify a duration. I can specify a permanent duration, but I'll just say an hour. And then, sorry, create cluster. There we go. So now we create a cluster. This will take, again, about 10 to 15 seconds, hopefully quickly. Otherwise, I'll abandon it. And once this is done, what I'll show you is that, like, the fact that Crucible actually comes with a whole bunch of cool, a whole bunch of tooling built into it. So you don't need to download a whole bunch of things. It's really nice to use from within CI and CD environments. So, from within scripts. So, for example, you can use kubectl just from within Crucible, because it has it built in. You just specify the cluster that you wish to connect to, specify the ID that was printed out just above, and then say get pods, for example. And we can see that our newly provisioned cluster has no pods in it because it's newly provisioned. And another tool that comes with it is Qbox, which is a neat little tool to demonstrate, that you can use to basically view the things that are running within your cluster, see the logs they're printing out, see some metrics on those clusters. Cool and useful tooling. And the final tool that is embedded is Helm. I don't have any Helm config to apply, so I'm just dumping the Helm help text, showing you that the Helm command line tool is actually built in. But you can do anything that you'll be able to do with Helm. And it's all nicely built in and wired up to communicate with your Crucible clusters there and then. So you don't need to deal with setting any Kubernetes config. Cool. So that's most of the demo. What I'll just show you very quickly is that it's extremely easy to integrate with Crucible. We have, like, nice integrations with all of the sort of with big popular CI and CD environments, and we have sort of detailed API docs so that you can see all of the you can do anything that you'd be able to do via the CLI or via the web interface, via the API, and it's very easy to integrate into whichever language that you happen to be using. Cool. So that, broadly speaking, is it. I will quickly, the last thing I'll show you, or the last thing I'll mention, thank you all again for taking the time to come and listen to me talk, but I'll just quickly mention that what we've got is a little discount code. So if you're interested in trying out the service, go to the website, use crucible.com, and then open up the chat box in the bottom right, type in Manchester, and you will get, like, or we'll automatically upgrade you to the $50 a month plan. It's neat. It gives you loads of credits. It gives you, I think, allows you to provision, I think, 150 clusters a month. So you can, you should be able to sort of really get started with that amount of money, really. But yeah, thanks again. Let me know if you have any questions. If anyone has any questions, put them in the chat. Otherwise, I'll hand back over.
Nice one. Thanks, Ben. That was really cool. Nice, slick live demo as well. Everything worked as expected.
Yeah, it did, just about. Cool. I will stop sharing.
Cool, that's better. So one question I had is with regards to how Crucible is working under the hood, if that's something that you're happy sharing details on. I'm curious to see, exactly how you're bootstrapping these clusters, if there's any, what tools you're using, that kind of thing.
Yeah, so under the hood, most of it is fairly custom. Most of it is sort of, there's not a great deal of magic under the hood. It's mostly sort of there's a proxy that sits between. I use traffic as a proxy that sits between the actual Kubernetes cluster, and it handles the assignments of the ports for me, so that I can co-tenant some clusters, especially on the So that handles a lot of the port assignment. Under the hood, it's actually using K3s. I'm creating K3s clusters. Mostly
nice.
For speed.
It's good to hear.
Yeah, I know, right?
Nick works for Rancher, right?
I know. I recognized the logo.
Did you set this up, Nick?
You know what? No, not at all. Not at all.
No, I thought you might appreciate that. Under the hood, it's actually using K3s just for those are the clusters that I found spun up the fastest. And yeah, it's very handy. What backend cloud does it use? Can we specify the backend cloud of our choice? No, at the moment it's just AWS. So far that has been enough for most people. I do have some requests, and there is a backlog there is a backlog item to add GCP first. I'm very open to adding other clouds if people have particular requests. Write to me, right in the chat, and we'll get right back to you.
Cool. Just give folks a few more minutes in case they have any further questions.
Yeah, totally. Cool. Yeah, so I was meant to set up an automated promo code redemption thing. I didn't, so it just sends me an email. It just sends me a message, so I upgrade the accounts manually. But I figured that was fine. That was close enough. So to anyone who's now trying to sort of write me messages, I'll get back to you in 10 minutes.
It's the mechanical Turk model.
The rest isn't the clusters work. It's just the promo codes, I promise.
That's what you say, Ben. I bet you're sat there all day just manually creating these clusters as fast as possible.
So is it just yourself that's hacking on Crucible at the minute, Ben, or have you got any other people that are contributing to it?
Yeah, so I've had on some of the I had a couple of contributions on some of the front end, the sort of the open source user facing things, but on the core thing, it's really just me. There was another guy I was trying to bring on board, but I haven't so far convinced the guy I'm hoping to turn into a co-founder with me. But still time. We'll see.
Keep twisting his arm. Well, I mean, with this kind of exposure, surely that will go some way towards convincing him that it's
guaranteed win.
That's the idea. Yeah.
I put the yacht order in.
But yeah. I don't know. Do we have any other questions? Well, OpenStack, I see. That's more fiddly.
Cool. Well, I guess that's it for questions. Obviously, it's up to you, Ben. If you're going to hang around for the rest of the meetup, people can maybe ask any more questions in the YouTube chat. Alternatively, just as a reminder, there is the Slack channel on the Kubernetes Slack. Although I also think that the Manchester meetup might have a Slack channel on the Cloud Native Slack as well. So. Yeah, we do. Yeah, too much Slack.
and as and feel free to write either via the chat or via the.
Of course. Excellent. So Jenny, Martina, how's it going?
Good. Yeah.
Excited.
Yeah, quite.
So, tracing microservices with Opentelemetry and Jaeger. So this is one of those talks that seems to have already caught the attention of a few people. There's a chap I know that runs a really awesome company based up here in Edinburgh, actually, a company called iDelta, who work a lot with tools like Splunk, and he seems super interested in this talk. So yeah, looking forward to it myself as well. Is it based on, I assume it's based on your practical experiences and lessons learned at Book and Go?
Yeah, pretty much. So I'd kind of give a bit of an overview and then how we do things at Booking. So hopefully you guys will find it useful.
Excellent. Excellent.
Yeah, and I'm giving a bit of an overview from the point of view of a developer using the service.
Oh, of course. Yeah. That's cool. That's cool. Guys, quite often, because I'm an infrastructure, like my background is mostly infrastructure, and it's very easy for me to completely forget that actually the target audience for all this infrastructure that I build is actually, not other infrastructure people. It's, developers and people doing actual real world stuff versus me just wiring things together and getting confused over software-defined networking.
Breaking stuff,
yeah. Cool. In that case, we've had one question from Rosak.
How do
for yourself, Ben?
How do you see it scaling with hundreds of releases a day with multiple interconnected microservices? Yeah, I mean, I'm not entirely sure how the. I suppose I get what you're saying. The multiple interconnected microservices. So importantly, each cluster is running on its own sort of dedicated machine, but it only exists on one machine. So the interconnected microservices I expect to be not a problem because it's sort of inter-process communication at that point. In terms of hundreds of releases, it should scale because fundamentally what I'm doing is spinning up hundreds of I've tested spinning up hundreds of Kubernetes clusters. Because what it's doing is creating Kubernetes clusters under the hood. There could be a slight delay. Basically, there is only if I have a number of Kubernetes clusters that are already created, if they are all of the pre-provisioned nodes are already taken, you may have to wait up to 40-50 seconds for a new Kubernetes for a new node to be provisioned. But in practice, that happens very rarely. It's only if I get a very big spike. In sort of, I haven't experienced it other than in sort of artificial load tests, which pushes the time up to sort of 30 to 40 seconds rather than sort of, 10 seconds, which is much more usual, if that answers the question.
And one last quick one from Danny Burke. How did you come up with the name?
How did I come up with the name? Crucible, sort of the idea of a regular crucible, or sort of, a place in which you sort of test things to breaking point, right? That was the idea. That was the sort of, that was the idea of testing things at high heat, at extreme pressure. That was the idea for Crucible. Then I chucked a K on the beginning because that was more Googleable. Does that answer the question?
That's what we all do, or just open the dictionary at K.
Yeah.
Cool. Okay, in that case, if Jenny and Martina, you're ready, we'll move ahead with the next talk. If you want to...
Spot, so I'll be off.
Cool. Right, I'll drop us lot out and hand over to yourselves then. Okay.
So hi, I'm Jenny, I'm a platform engineer at Booking.com, and today I'm just going to be talking about tracing with Opentelemetry and Jaeger. So I'll give an overview of tracing and Jaeger and going over the components and the deployment methods in Kubernetes. And then after that, Martina will be giving a short demo so we can see some tracing in action. So when it comes to cloud native applications, they're normally very complex distributed systems in which are really hard to debug. And then microservices just kind of amplify this problem. So each time a request is executed by the architecture, it might require the participation of maybe dozens of other different services. And then if you consider that if you're on call and you get an alert, you'll be looking to your observability tools to be able to answer questions like, which services did a request go through? What did every microservice do when processing the request? If the request failed, where did the error happen? And how was the execution of the request maybe different from the normal behavior of the system? And depending on the scale, you might find that you encounter a bit of an observability problem. So in some cases, logs and metrics are enough, but within a really complicated microservices architecture, where there's lots and lots of components, it becomes more important to be able to understand the communication networks, because these are really deep systems where you have this problem that you might not have experienced previously. And I just think that this famous tweet just kind of sums up this problem with microservices. So what's wrong with logs and metrics? Well, logs and metrics both have their own use cases. So for example, you'll use metrics for alerts, and they're really cheap to collect, and since numeric values just can be easily aggregated and to reduce the overhead of transmitting that data. They're also pretty accurate, why they're really useful for alerting. This is where tracing isn't really applicable, because traces are sampled and averaged, so you wouldn't really want to rely on them for alerts. But metrics alone aren't really capable of telling us a more detailed story to explain why things are going wrong, which is ultimately what we want to find out. And it's because of this aggregation that makes metrics less useful for telling the detailed story, because by aggregating the data, you kind of throw away a lot of the context. And then, so what about logs then? Well, logs have a really similar problem where logs lack correlation across services in this complicated architecture, which is what we really want to be able to answer some of those questions before. They were both logs and metrics were designed for like a monolith system. So they're focused on observing the behavior and the health of some single component. But what we really want is to know the end-to-end story of requests that touches many different components, so we can start understanding why things are going wrong. So in a sense, we kind of want a bird's eye view of the system. But at the same time, once we've identified whatever components at fault, we want to be able to drill down and get a view on exactly what happened to that request in that component. Now, most of the tools can tell us about what happened in general, but they really lack granularity and context to be able to analyze a specific request. So that's kind of where distributed tracing comes in. Tracing is one of the pillars of observability, and you achieve it by instrumenting your code. So you do something like mark the code before and after some operation, and then whatever's stored in between that is stored in a data structure called a span, which is just a unit of work which is timed. And you can store information about it, like what time it started, how long it took, and some other metadata as well, like IP addresses and things like that. And spans can reference other spans as well. So what you'll usually have is a span, which is a child of another span. And so although tracing is really useful, it's not really enough on its own in this microservices world, because what you really need is a way to tie all these spans together. And that's where distributed tracing comes in, because it adds the idea of context propagation. And that's done by passing around an ID that's generated at the first point of contact in the system. And then you just pass this ID along downstream pretty much. And it's through that mechanism that later on we can tie together all these spans and reconstruct the whole path of the request through the components of a distributed system. And then you can go in and view these as a graph of events which are causally related. And then that just kind of allows us to reason about how a system was processing a given request. So that's all great, but then how do you get tracing instrumentation into many services which might be implemented differently? And that's why the Open Tracing project was created for a standardized tracing API, which can be implemented by different tracing vendors independently. and can be used to create vendor-neutral tracing instrumentation. So open tracing focused exclusively on distributed tracing. There's also Opentelemetry, which is a set of libraries which offer like a bigger range of telemetry. So it's not just tracing, but it's application metrics as well. But both Opentelemetry and Open Tracing, that the code bases are being merged into the new Opentelemetry project. And the idea, I think, is basically to kind of pick out and choose the best bits from each project, and then put them into the new one. So Opentelemetry provides the libraries, components, which you'll need to capture the telemetry from your services. Specifically, it captures metrics, distributed traces, and I think logs as well, it's incubating. And then you can just send this data to backends like Prometheus or Jaeger and others for processing. And so then I wanted to talk about Jaeger. Jaeger is a distributed tracing platform. It's inspired by Zipkin, and it was started by Uber in 2017, and now it's a graduated CNCF project. And it's basically a set of components, and it supports open sensors, open tracing, Opentelemetry libraries. So they all work with Jaeger. So here just shows all the different main components of Jaeger. There is another one as well, which I'll talk about next. But basically here you've got the application, and as part of the app, you'll embed a trace as a client, as a library in the app. And then the client is the component which knows how to record things. So if you use open tracing, or Opentelemetry or open sensors for what to record, the client will just go and create those spans, put them into batches, and then send them via UDP to a specific port. And then the agent is responsible for retrieving those and then sending it to a collector in a bit more of a reliable way. So on Kubernetes, you've got two options to be interpreted as local host. It can either be the node where the pod's running, or it can be the pod itself. So that means you've got two options for running the agent in Kubernetes. You can run it as a daemon set or as a sidecar, and then the collector will go and write that data into a more permanent storage, so like Cassandra or Elasticsearch or whatever it might be. And then once the data is in the storage, the query component will go and retrieve data from storage on behalf of the UI. And so that they were the main components, but you might find that your storage can't keep up because maybe you've got a sudden spike in traffic. And then in that case, the collector will just have no choice but to drop the data. So what you can do instead is you can do Kafka-based ingestion. So the collectors, instead of writing to storage, they'll write to Kafka. And then so the collectors will write to Kafka, Kafka will write to the ingester, which writes to Elasticsearch, for example. And that's for absorbing like really high traffic. So it's a lot of components there, and it's probably complicated to deploy and manage. So there are a few ways to deploy. The simplest way of running Jaeger is the all-in-one Docker image. It contains everything except the ingester. So you've got the UI, the agent, the query, the collector, and also an in-memory storage component. So you can just run the binary, and it will start all these components on the same process, and you can just start working with it. When you move to production, you might want to at least split the query and the collector, because you probably want the collector to be highly scalable and available, whereas the UI is not. It's not really the same. So you can probably have just one replica for the UI, but the collector should probably be distributed with maybe more replicas. So you might want to use a deployment, because then every component is a binary. So in Kubernetes, you can just deploy them on their own pods and then scale them as needed. So you can do that via Helm, where you just specify the chart values and install the chart. And you can also use the Jaeger operator. So you can install the operator via Helm, and then install individual instances of Jaeger. There's also Kubernetes template files as well. So you could even just kubectl apply -f the template files. So at Booking, we originally deployed Jaeger using the operator, but it meant that making changes to one level became a bit difficult because they were all the components were coupled together. Whereas if they were all separate components, it'd be much easier for us to make a change to one layer, for example, the Elasticsearch layer, and also to roll out changes to a layer region by region in a more stage-safe fashion, because everything's decoupled. So yeah, we decided to create some new Jaeger clusters, and we did this using the Helm chart. So how it works is we have an agent sidecar on all the pods, and they receive individual spans, and then they send them off to collector. And we have one collector in every cluster, which then writes the spans to Elasticsearch, which we only have in one cluster. And then they return the results to the AUI. But we didn't. This stuff wasn't without its problems. We did have problems with this. So in the past, so we had noticed that from our dashboards that Jaeger was representing roughly half of the traffic going through the ingress. Obviously, that's not great, but it turns out that Elasticsearch has a built-in service discovery mechanism. So the client can query Elasticsearch via the ingress, get a list of nodes, and then once it's got the list of nodes, it'll just connect directly to the nodes bypassing the ingress. So initially we tried to enable sniffing, but the nodes were not being discovered. So after some digging, we found out the reason for this is that the underlying client being used sets the default scheme to always be HTTP. But the problem is that we run our Elasticsearch clusters using HTTPS. But we could fix this by making a change to set the scheme to be HTTPS, and then if it works, we could send a patch upstream. So that's what we did. Forked the repo, made a fix to set the scheme, and then rolled out this new Jaeger collect image to our clusters to just kind of prove the concept. And it's not a great screenshot, but you can kind of see that we actually managed to decrease the load on our ingress by about 10 times. So yeah, once we'd confirmed that that worked, we created a patch which makes the scheme configurable as an option, and that was just recently released. Last thing I wanted to talk about is agent level tags. So Jaeger also supports these tags, which can be added to the process tags of all spans passing through the agent. So all spans from, you can add various different tags. So we've added tags like environment and region, and this allows us to filter users to filter spans based on these tags. So yeah, I think that's all I wanted to say. So I guess now it's demo time. You ready, Martina?
Yeah. Okay, I'll take over the screen. Okay. So hi, I'm Martina, and like Jenny, I used to work at Booking.com. I'm now in the process of changing jobs, and today I'm gonna show you hopefully something a bit useful. So the perspective of a developer on using Jaeger. So I'm just gonna reiterate on a few points made by Jenny. So for example, why do we use tracing? So in the past, we just used to have monolith applications. So tracing was born out of a change in how we build and in our architecture. So what was previously a big application where we could have just used a probe to detect the health and various problems, we needed a different different solution. So by having many different microservices, which we could have the same approach of probing each single one of them with metrics and logs, like Jenny said, but that's usually not enough. So that's why we have tracing. So tracing, like tracing uses what was mentioned before. So like uses the concept of a context, and what a context is literally just a virtual container which is associated with one single request. And this allows this context is propagated through each of the different parts of the request. So for each different service or each different boundary that this request goes through. And usually in this context, we store information such as our unique ID that we can use to query that request. So after this context has been propagated to the very end of the request, Jaeger is then able to build and stitch together all these different pieces of the execution to build a call graph and build a timeline of the request, which looks a bit like this. So this is the equivalent representation in Jaeger of a request and its lifespan. So as you can see, we have a service A that has a called service B that then has called C and D, and etc. So I'm gonna do a quick demo with Hot Road. So Hot Road is a small project which is included in the Jaeger repository. You can now find it under Jaeger tracing Jaeger examples Hot Road, and this is taken from an original walkthrough by Yurish Kuro, the creator of Jaeger, and you can check it out. I've added the link in the references to this presentation. So what I'm gonna do is I'm gonna start the Jaeger backend and UI, and then run Hot Road, and literally. So I hope you can see my terminal. So literally running Jaeger, and then application. So Jaeger is going to start on localhost on this port, and we can check the Jaeger UI. So we can see the Jaeger UI from here, and then this is what Hot Road looks like. So Hot Road, ROD stands for Ride on Demand, and basically what these 4 buttons represent is each of them represents a customer, and Hot Road. We know that this Rides on Demand system is made out of a few microservices, which is we can also see by looking at the logs of this service. So we see that we have 3 microservices that have been started up: root, front end, and customer, but we don't exactly know how they're interlaced and how they work together. So we will use Jaeger to find that out. So by clicking on one of these buttons, we send a fictitious car to one of these customers. So I'm just going to click on one of them now, and we have some information. We get some information about this request that has gone through. It tells us that it has taken 759 milliseconds. And now we'll try and see what Jaeger got just out of this request. So if we go to the system architecture tab, we already have like an architectural kind of overview of that request. This was literally generated just from running that single request, which is great. So we know that the starting point of our transaction was the front end service. So that's the one we're going to select. And we're going to look at all the traces for the last hour. So firstly, if we look at the trace, so like I decided to keep this demo short because I understand that most of you might be Jaeger users already, or might already know how it works. So I'm not going to go much in depth of what Jaeger offers, and you can have a play with the Hot Road application yourself. It's quite useful. So we have some basic information around the request, such as the endpoint where the request started from and the time. You might notice that the time is a little bit different. So here is 737, and this is because this is measured from the backend, while this one is measured from the front end in the JavaScript front end. So we're going to have a look as well. So we already have a set of the services involved in the processing this request. And here we have our main view. So the first thing you notice is that we've got a timeline, and as well, like we can see what each service called. And this is where Jaeger comes in handy. So for example, this driver service has called Redis sequentially. So as a developer, you would be able to spot that and see it as a potential for optimization. So potentially these requests could be done asynchronously. And Jaeger would still be able to track this and show us in a different way, like here, for example. So another thing that we notice is that errors become quickly visible. So like traces that have interactions that have ended in an error are shown with an exclamation mark on it. And as well, another useful thing is that we've got, so like when we started our application, all our logs were produced in the same standard output. So we had no differentiation between different services. And Jaeger allows us to have some context for the logs. So as well, we have our logs get contextualized. Another useful thing about is that was mentioned by Jenny as well is the tags. Tags are searchable, and we can literally just find spans that have to do with exactly what we want. Okay, so I think this is like all I have to say for the demo part, and I added a quick one around what we were doing specifically at Booking.com. So at Booking.com, we had something that we called the observability standards, and we had a section which was around tracing. So I've not named them out all because it would be long, but I've just taken out a few of them. So they're meant to be technology agnostic, but I'm going to do a few examples in Java just because that's what I was more used to. And so a few good habits and useful bits and bobs that we had a Booking where as a developer, when you instrument a service with a Jaeger out of the box, you still might want to change a few things. The first things that we changed straight away was limiting the sampling rate in production, and I'm sure our colleagues from infrastructure appreciate this because having too many traces some traces might not be sampled if the volume of your application is too high. And so we used what is called a sampler. So there's different types of samplers. I'm sure you can research those yourself. One of the simplest ones was the probabilistic sampler, which I'm going to talk about briefly. Then another thing we did was disabling logging in production to avoid the pollution of the logs, and just using the Jaeger debug ID to debug or reproduce issues, or as well logging the span ID in the logs of the service, so to be able to correlate a log with a span. So I'm going to go through this one a bit more in detail. So for samplers, as I mentioned before, we in order to safely process all the spans, we want to reduce the amount of requests that are sampled, so the amount of requests that actually appear eventually in our Jaeger UI, so not to get any dropped spans. And for example, this is an example of it's just literally a one-liner to set a probabilistic sampler with a 10% probability of sampling a span. So this is literally from the application properties file of any Java application. You would literally just set that. I've linked an article to tuning Jaeger performance as well for more information on this topic. So the next thing I wanted to talk about is span logging. So whenever we instrument a service with Jaeger, we have noticed that it logs each of the spans that it produces. So this means that every time a span is produced, a new log will appear on the application. So you can turn this off and keep your logs clutter-free. So that makes debugging a lot easier, and you can and also it saves you a little bit of money in not saving huge amount of logs. So another thing which wasn't very well known, and we added that to our observability standards, was the use of the Jaeger debug ID. So this is a very, very simple concept, and it's a feature that most implementations have, the Java one for sure. It's literally making Jaeger able to recognize an HTTP header with the name Jaeger debug ID. So whenever you send a request that has this header with some correlation ID that you decide, then this forces that trace to be produced as a debug trace. And this is useful because of what we said earlier. So like we said that we don't sample all of the requests usually to keep the volume a bit lower. So if we want to replicate an issue that is happening and we know how to replicate it, we can produce a trace for that request by explicitly specifying this header. So yeah, that's all from me. This is a few links and references. And yeah, I'm sure that there will be a way to link to this presentation. Thank you.
Thanks, folks. That was really good. So, any questions from anyone?
Surprised to see, well, maybe not surprised, but there's already a few folks using Jaeger that are watching tonight, which is good to see. I say surprised because I've not used it myself. So that's my ignorance that's showing. But yeah, as an infrastructure, sorry, Jenny, go ahead.
Yeah, explicitly decided to keep it a bit short, and just in case we had Jaeger users already among us.
No, it was all new to me. But yeah, I was going to say, as an infrastructure person, just to Jenny's point from earlier about the amount of information, the amount of bandwidth it consumed. Yeah, it can be kind of scary when you get complicated pieces of monitoring infrastructure like this that generates so much data. So how much of an operational burden has that been to run? And I guess, I mean, I suppose I know the answer to this, but has it been worth the amount of that amount of operational burden in practice?
I think you can ask Martina. She was one of the users. But yeah, I think that the feedback was good. So I think it was a good result.
Yes, to instrument this is usually very quick and easy. So, for example, for a Java Spring Boot developer, it's literally as easy as adding a dependency and then dealing with the consequences. So, literally a few minutes job.
So, just as a shameless plug, if anybody is interested in Opentelemetry generally, I interviewed Austin Parker, who's the maintainer of Opentelemetry, on my podcast a few weeks ago, and I'll put that in the link to that in the chat.
That was shameless. You're right. So, any cool war stories, having deployed this and having started to make use of it, and developers such as yourself, Martina, making use of it. Any cool war stories where it's been absolutely invaluable and you turn around and gone, but this thing that it would have taken us like a week to diagnose, we've diagnosed it in a matter of minutes because we've managed to click through and find out what's going on?
Yeah, I'd say there have been a few cases where it's been really, really handy, where it's been really, really difficult for us to find out what's going wrong. And then when we look at Jaeger, the information is there and it's really handy. It's easy to find where things are going wrong. And I think that's the main point. So, yeah.
So another question here: have you got buy-in from all developers to implement tracing on all apps? it only really becomes useful if it's implemented across the board.
So yeah, that's a work in progress, getting there slowly. But yeah, definitely there's more.
There's quite a lot of politics around it because so I think developers are very open to using Jaeger because some of them have already seen how it comes to be really useful during live issues, while there's some push to use app dynamics as well. So I think eventually we're gonna keep both, but there's been a lot of politics around this issue and around using Jaeger. But it seems that a lot of developers have bought into the idea.
But I mean, in terms of open tracing, if I'm the Opentelemetry stuff, am I right in thinking that actually integrates with a whole bunch of different analysis tooling, including proprietary stuff, right?
Yeah, I think that's the idea. So it's like vendor neutral. So it's just
yeah, vendors just maintain their own plugins to integrate that into whatever system you want to use to be able to analyze traces.
Yeah, exactly.
I also posted earlier in the chat for folks who may have missed it, the Dapper research paper from Google, which is where a lot of the ideas behind distributed tracing come from. It is a super interesting research paper for anybody who's interested in the conceptually where a lot of this stuff originated. Okay, well, I guess if we haven't got any more questions, then we've come to the end of this evening's proceedings. Thank you, Jenny. Thank you, Martina. Thank you, Ben. Oh, one more question. One more question around how long you keep the data. Have I missed one in the chat somewhere? Am I missing something here in the chat about other question around how long you keep the data for?
Yeah, I'm not seeing that.
No, let me just check on YouTube and see if we can, or if you could repost that question. It doesn't seem to have filtered its way down.
It's got lost in the post. Should have had some tracing, then we'd know where it is. Maybe it's using UDP.
Oh God.
So we've missed one there. There's one from Pratik about. So he says he hasn't used Jaeger, but is it something similar to what's provided with Istio?
No. So I think generally people use Jaeger and Istio together. I think that's generally what people
Istio
do.
gives you the visibility at the like a networking level, whereas Jaeger actually gives you the full detail from the application's point of view.
Yeah.
Yeah.
Okay, well, perhaps we might have to give up on that last question unless it appears imminently.
Blend network.
Yeah. So thank you to all our speakers, Jenny, Martina, Ben. It's been a super interesting evening. Thank you to all you for, here we go.
Jenny and Martina thought they're off the hook.
Yeah. So as tracing data loses its usefulness over time, how long do you keep the data at Booking?
So I'm no longer in Booking, but I think when I was there, it used to be kept for 7 days. And yeah, so it's useful like after a live issue, even just for like to understand what has been going on as well, if you haven't detected the issue using Jaeger. So yeah, it might have changed now.
Okay, well, yep. Thank you to everyone who's watching. Have we got any upcoming news, Nick? I don't think we've got a definitive date for the next one, although likely next month.
Probably next month. Yeah, obviously. Again, actively looking for more speakers. So yeah, by all means, get in touch. We have, and this is where I always fail. This is where I always fail to have these URLs and this information handy. But there is a speaker submission form on the meetup page, which I'm sure you can all find if you're already here. And yeah, we also have a GitHub repo as well, where you can submit an issue if you want to come along and speak. So yeah, if there's anything that you want to talk about that fits within the cloud native or Kubernetes ecosystem, we'd love to have you along. Yeah,
or any ideas on topics that you'd like to hear about that we can go out and find.
Yeah, of course.
Some folks who can come and speak to us about that. So please do drop us any suggestions of particular topics or particular speakers. All right. Well, have a good evening, everybody, and we'll see you next time.
Cheers, all.
Cheers.
Thanks.